Good morning. In previous video we have studied about the types of solution. Now we will start how the concentration of solution represents. Concentration of solution represents in terms of concentration terms. There are the certain terms by which we can represent the concentration of the solute or solvent in a solution. So these terms are, first one is the mass percent, which I have already discussed in previous video, but I repeat it. Mass percent. Mass percent is the amount of solute per 100 gram of solution. What is this? Amount of solute or mass of solute per 100 gram of solution. Mathematically it can be expressed as mass percent is equal to mass of solute upon mass of solution. Here we are taking solution, not solvent, multiplied by 100. 100 is for percent. Second one is the volume percent. Volume percent mean volume by volume. Solute is also expressed in terms of volume and solution is also expressed in terms of volume. So it is the volume of solute per 100 ml of solution. What? Volume of solute, या volume in ml of solute per 100 ml of solution. It is volume percent, or we can say volume by volume. Volume of solution in ml, volume of solute in ml upon volume of solution in ml multiplied by 100. It is the volume percent. Next one, weight by volume. Third concentration terms is weight by volume. Mass by volume percent. As you see, it is W by V. That means amount will be expressed in terms of mass and amount of solute will be expressed in terms of mass, whereas the amount of the solution will be expressed in terms of volume. It is the mass of solute in 100 ml of solution. Naturally, mass will be taken in grams. Mathematically, it can be expressed as mass of solute in grams upon volume of solution multiplied by 100. These are the three basic terms which I have already studied in class 11th also. Next one is the mole fraction. It is quite important because numerically purpose and outflow, which will be studied further, totally depend upon the mole fraction. Mole fraction that you have already studied in class 11th also. Mole fraction is what? It is the ratio of the number of moles of a particular component to the total number of mole of solution. ratio of the mole of particular component to the total number of mole of solution. It is ratio of the mole of the number of mole of particular component to the total number of moles of solution. Suppose we have a binary solution, then there should be two components A and B. The number of moles of A is Na and number of moles of B is Nb. I am explaining mole fraction at the top of the board. For binary solution, two components, A and B. Number of moles of A is Na, number of moles of B is Nb. Mole fraction expressed as Xa. Then Xa will be number of moles of particular component. That means if we are going to find out the number of mole fraction of A, we should take number of moles of particular component as Na. And total number of moles of solution. So there are the two components A and B. The total number of mole is Na plus Nb. It is the mole fraction of A component. Similarly, mole fraction of B component, Xb, it is X, which is equal to Nb upon Na plus Nb. For a particular solution, if we add the mole fraction of all components, it will always equal to 1. Just like Xa plus Xb is equal to Na upon Na plus Nb. Right? Plus Nb upon Na plus Nb. Simply add by taking LCM. LCM will be Na plus Nb. We get Na plus Nb. That means sum of the mole fraction of the all component present in the solution always equal to 1. If there are the three components, then Xa plus Xb plus Xc equal to 1. If there are four components, then Xa plus Xb plus Xc plus Xd is equal to 1. Clear? Now next term, molarity. That you have also studied in class 11. Very simple term, but numerically it is very important. Molarity. As you know, it is represented as capital M. Simply, molarity is what? Molarity is a concentration terms which express the concentration of solute. Molarity is what? Molarity is the number of moles of a solute in 1 liter of solution. Number of the moles of solute present in 1 liter of solution. So simply, if we write molarity, number of moles of solute upon volume of solution in liter. Volume of solution, not solvent. Mind it. Further, if we extend it, how will we find out the number of moles? You know, number of moles is the gram weight if we take the gram weight of solute W, it will be divided by the molecular mass. So I am taking gram weight of solute as WB and molecular mass of the solute as the MB. So it is the number of moles. Now volume of solution in liter. It is not necessary that in each and every question we will get the volume of solution in liter. Sometimes they give the volume of solution in terms of ml also. So suppose we take volume of solution in ml. Then we have to multiply it by 1000 to convert volume of solution in ml to liter. It is the molarity. Very simple concept. WB, weight of the solute, MB, molecular mass of the solute, 1000 is 1000 and volume of solution in ml. If you are having a volume of solution in liter, no need to put 1000 here. Okay? Since volume is involved in a molarity and volume change with the change in temperature, hence molarity depend upon temperature. It is depend upon temperature. That means molarity change with change in temperature. It is the one more concentration terms. I think it is the fifth one, which is molarity. It depend upon the temperature. It is number of mole of solute in volume of solution in liter. If we convert the number of moles in terms of mathematics expression, it will be WB by MB. 1000 to convert the volume in a liter, because we are taking a volume of solution in ml, so we have to put 1000. Next one is the molarity. Molarity, sixth. Molarity and molarity have a small change. Molarity also have a number of moles of solute. It is the number of moles of solute present in 1000 gram of solvent. Number of mole of solute present in 1000 gram of solvent. In 1 kg of solvent, we can write it 1 kg of solvent, not solution. It is solvent. It is expressed by a small m. Mathematically, if we express molarity, number of moles of what? Number of moles of solute. Mass of solvent in kg. Mass of solvent in kg. Okay. Number of moles of solute that we can find out by using gram weight of solute. Solute is represented as B. Molecular mass of solute MB. If the mass of solvent is given in gram, then we have to put 1000 here to convert it in kg. It's a expression, mathematical expression for molarity. It is temperature independent quantity. Temperature independent quantity. That means it will not vary with the temperature. That means it will not vary with the temperature. Okay. In next video we will study about the Henry law. Since we have already studied the types of solution, there are the 9 types of solution according to the physical state of the solute and solvent. Out of 9 types of solution, 3 types of solution are important. First one, where the solute is solid. yani, and solvent is a liquid. That means solid liquid solution. Second one is the liquid liquid solution, and third one is the gas liquid solution. Okay, since the video have already prepared for the 15 minutes, it will be very difficult to upload at YouTube. So I will express these things in further video. Thank you very much.